Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of optimization. So as per the problem, prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 over 27 of the volume of the sphere. So the first step is to draw a diagram for this problem, and we should show the sphere with a cone inside it. So let's assume this is the sphere. Now we can draw the cone. This is the center of the sphere. The radius of the sphere is r. Let's assume this point is the center of the circle that makes the base of the cone. This is the radius of base of the cone. Let's assume it's small r. Now we can label the points. Triangle OBC is a right angle triangle. Let's assume their distance from O to C, the center of the sphere, to the center of the base of the cone is x. The distance from O to point A is r. So the height of this cone is x plus r. Now we can analyze triangle OBC to find the radius of the base of the cone in terms of x and r. Triangle OBC is a right angle triangle, so we can use Pythagorean theorem equation. C represents the length of the hypotenuse, and that's r. We can isolate for small r the radius of the base of the cone by subtracting x squared from both sides. So this is the expression for r squared. We have to find the volume of largest cone that can be inscribed in this sphere. So we should analyze the formula for volume of a cone. The formula for volume of a cone is 1 over 3 pi r squared h. R is the radius of the base of the cone and h is the height of the cone. We found out that the height of the cone is x plus r, and r squared is equal to big R squared minus x squared. So we can do the substitution for r squared and h. Now we can simplify this expression by distributing the terms in the parentheses. We can use the FOIL method. Now we can rearrange the terms in the parentheses starting with x cubed. So this is the expression for volume in terms of x. Now we can write the domain for this volume function. X represents the distance from point O to point C in the diagram. X cannot be a negative number, but X can be equal to 0 if the base of the cone coincides with the center of the sphere. So X has to be greater than or equal to 0, but X cannot be equal to R. Because if x is equal to r, then point C will be on the sphere. So there's a very important concept you need to understand to solve this problem. So this is the domain of this volume function. Now we have to find the derivative for this volume function and set the derivative equal to 0 to find the x values at which the tangent is horizontal, because the tangent will be horizontal at the maximum points in this volume function. Now 1 over 3 pi is a constant, so it will stay as it is outside the parentheses. We have to find the derivative of the terms in the parentheses. For the first term, minus x cubed, we can use power rule. So minus will stay as it is. The derivative of x cubed is 3x squared as per the power rule. In the second term, r is a constant, so it will stay as it is. As per power rule, the derivative of x squared is 2x. In the third term, r squared is a constant, and the derivative of x is just 1. And r cube is a constant, so the derivative is 0. R is a constant because it's the given radius of the sphere. Now we have to simplify this expression and set the derivative equal to 0. This is a quadratic equation in terms of x. We can factor this equation. We can start by doing common factoring. We can factor out the negative sign. That will make 1 over 3 pi negative. Now we can factor this equation. This is a complex trinomial. We can use decomposition method. We can break up the middle term 2rx as 3rx minus rx. Now we can use the grouping method to pair up the terms. So from the first pair, we can factor out 3x. And from the second pair, we can factor out negative r. Now we get two cases. I get x equals r over 3 as the first solution. X equals negative r is the second solution. The second solution lies outside the domain we found for x, so it's an invalid solution. So the only valid solution is x equals r over 3. Now we can use the first derivative test to check whether the volume is maximum at x equals r over 3. So for that we can use the number line method. We can use the test value on the left side and the right side of r over 3. On the left side we can use the test value r over 4, and on the right side we can use the test value r over 2. So we have to sub in these test values in the expression for the derivative and check whether the sign of the derivative is positive or negative. In other words, we want to find whether the function is increasing or decreasing on the left and the right side of x equals r over 3. So I'll write the expression for the derivative. Now we can sub in x as r over 4. So I found a common denominator so that we can combine these fractions. Negative 3r square minus 8r square is negative 11r square, and negative 11r square plus 16r square is equal to 5r squared. So this expression has a positive value. That means on the left side of x equals r over 3, the value of the first derivative is positive. That means the function is increasing on the left side of x equals r over 3. Now we can do the test on the right side of x equals r over 3. So we should sub in x as r over 2. Negative r square plus r square will cancel each other out. So we'll get a negative value for first derivative. That means the function is decreasing on the right side of x equals r over 3. So that means the volume is maximum at x equals r over 3. Now we can find the expression for the volume of the cone. We can use this equation to calculate the volume of the cone. R over 3 plus R can be combined by finding a common denominator, which is 3. So R over 3 plus 3R over 3, which is equal to 4R over 3. R square minus R square over 9 is equal to 8R square over 9. The common denominator is 9. So the volume of the cone is 32 pi R cube over 81. We have to prove that the volume of the largest cone is 8 over 27 of the volume of the sphere. The formula for volume of a sphere is 4 over 3 pi R cube. So we should multiply this formula by 8 over 27 and check if we get the expression for the volume of the cone. Four times 8 is 32 and 3 times 27 is 81. So we get the same expression as the volume of the cone. That means the greatest cone that can be inscribed in a sphere of radius r has the volume, which is 8 over 27 times the volume of the sphere. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.